Hey everybody, I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey everybody. Gotta have my notes. It's John Myers from the KICKER UnMasked studios. Gotta have my notes. Alternator. Hey everybody. We have fun. Hey everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We got to thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey everybody. Don't forget right here, right now. We have got a great show tonight. Hey everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. 7:30 on Tuesday night. Housekeeping. From the KICKER UnMasked studios. Housekeeping. Right here, right now. Hey everybody. So, it's John Myers. Hey everybody. It's John Myers from the KICKER UnMasked studios. Hey everybody. From the KICKER UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey everybody. We have got a great show tonight. It's John Myers. Hey everybody. Right here. Hey everybody, it is Tuesday night, 7:30. You know what you've tuned in for. This is Unmasked, coming live from the KICKER UnMasked studio here in Stillwater, Oklahoma. You guys have waited 2 weeks for the next episode, and by gosh, it is here. So last week I had some fun. We went over all the exciting things that happened at Slamology. My ears are still ringing from sitting in that gosh darn van of Kyle Rutherford's. Good old Clippo tried to hurt me, and I think he did. But if you guys haven't seen that video, he tore a hole in the roof big enough to put a hand through. So yeah, it was absolutely incredible. Of course, Drew, just his vehicle is incredible as well. Of course, Steve Barber and Andy was with us the whole week. So if you guys get a chance and you haven't seen any of the coverage, go back and check it out. We're gonna have a fun show for you tonight. I'd like to say we have the usual group running the show, but we've got a new addition. But first of all, we've got Steven behind the camera back here doing a great job for me. He's going to get a workout tonight with what we're going to do, so there's going to be a lot of camera movement. You got Ernie back there running the keyboard, and JW, and new. You see a new face? Well, that's a new shoulder. There we have Colin Wilson. If you guys have ever read one of the KICKER manuals, you have seen his work. So he's going to be filling in, taking care of that social media spot for us, and I'm sure he's going to be doing a great job. If you guys are new to the show, make sure you hit the like and subscribe button. That's how we do this. We get no funding other than your likes and your wishes for new and exciting content. If you guys have anything you want to see, or guests you want to see, or things you want us to cover, please let us know in the comments or send us an email. As always, you can get an email out at support@kicker.com to the tech guys. If you have a question about the show or wants or wishes, they can relay that message to us. And if you're new, We always give away stuff at the end of the show. We're going to run this registration. I think JW said we're going to pump it out until 8:30. So that's just a little less than an hour from now. We'll close that registration. And of course, the prizes are going to be, the grand prize winner is going to get that BF100, that Bluetooth waterproof speaker. You're going to get the KICKER Unmasked t-shirt and koozie. The second place is going to get the TWS2s. Those are the in-ear earbuds that are totally wireless. I've got a set of those. They are in stock and shipping now. So we did get some more back in. For those of you guys that ordered some and were waiting for them, you should be getting them very soon. But those things sound incredible. And of course, the third place winner is going to get the EB400s, which are the weather-resistant, almost waterproof Bluetooth earbuds that do have one wire going between the left and right ear. So we're going to have a fun show. Today we're going to go into all different kinds of wiring speakers and why it's important to wire them correctly and what happens when you do and when you don't. So we're going to take a quick break. We're going to come back and we're going to jump right into some cool and interesting combinations of wiring.
It's been a long road since the original KICKER christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is KICKER.
Music is my passion, my livelihood, and it's in my DNA. My pals at KICKER Marine Audio gave me a chance to take the music what I love and listen to at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at KICKER Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard! This is your time.
Welcome back. We're about ready to dig into this, but always, I've got to thank you guys. Thanks for your support. We can't do this without you guys. I mean, we've got a bunch of the usual guys. You know, we've got Cornut out there. We've got Ashy. We got Bobby Burkett, and we've got Cassie. Thank you guys for tuning in, as always, every other week, and thanks for letting people know about the show. We really have a lot of fun doing this, and once again, I hope you learn something while you do it, because even I learn something as we go through this stuff. But speaker impedance, why do we need to know, and what are the problems with speaker impedance? Well, first of all, one of the biggest questions that people ask is, what is the difference between impedance and resistance? It's very simple. Resistance is DC, impedance is AC. So that's the difference between impedance and resistance. One is measured DC, and the other is measured AC. Now, when you talk about, impedance, I mean, it can be reactive. Things can change to the other parts in the circuit, where if it's DC, nothing's going to change that resistance. So that is one of the main reasons that we have to know what we're doing, is because when you start wiring things different configurations, the impedance and the resistance loads change greatly. And how does that happen, and why, and what do we need to know about it? Well, first of all, we've got a little display set up here with 4 speakers. We're not going to jump right into 4 speakers at once. We're going to work into this a little bit slowly, start with a single woofer. But one of the things I want to point out, if you notice, these are dual voice coil speakers. So a dual voice coil speaker means it's got 2 separate voice coils. Well, it's pretty easy on these comp subwoofers to figure out that this is one voice coil, this is the other voice coil. But what if you've got a speaker like one of our old L7s that you've got one terminal on each of the flat surfaces of the speaker, such as I have here. I'll see if you guys can see this. But if we look at this speaker, you've got 2 red terminals and 2 black terminals. The way to tell which voice coil is with what is the ones with the white dots are the same voice coil. So you have a red with a white dot and a black with a white dot. That is one voice coil. The other voice coil are the other 2 terminals. So if you're wiring up one of our older square speakers that has this configuration of terminals, just look for the dots and make sure that you realize that that is the same voice coil. So I'm going to set this guy down. This is one of our older L5s, believe it or not. This is almost a brand new speaker we actually dug out of the warehouse, so I pulled it out of the box. But yeah, this is a pristine, probably never ever played music through it, L5. So that's going to be a fun speaker to play with later. So Let's start talking about impedance and resistance. So first of all, what we're going to do up here is we're going to be measuring resistance. Now, the reason we're going to be measuring resistance is we're not putting any signal into the speakers. You do get something called impedance rise, if you've heard people talk about that. When we talk about a speaker's impedance, they call it a nominal impedance. Nominal means average. So a 4 ohm speaker is not necessarily 4 ohms DC. It's going to be close to it, but maybe it's not going to be exactly at 4 ohms DC resistance, but it's going to have a nominal 4 ohms of impedance. So let's go ahead and take our meter here. Let's turn it on. We're going to set this to the ohm setting. And hope you guys can see that meter. And as always, if you guys have any questions, feel free to pipe right in. I know JW's done a good job of bringing those questions up. So what we're going to do is we're going to talk about these speakers up here. Now these are our 8-inch dual voice coil Comp C speakers. They're rated at 4 ohms per coil. So I'm just going to randomly pick one coil, one speaker, and I'm going to go ahead and connect the leads of the meter to it. And it's going to give me our DC resistance. So the DC resistance on this voice coil is 4.1. Now it can vary greatly. It can measure, I've measured 4 ohm speakers that started out at 3.2 ohms. Some go up to 4.4. So long as they're somewhere with close to that 4 ohm, you're fine. So if you're measuring your coils, it's like, it's supposed to be a 2 ohm coil, but it's 1.9. It's still a 2 ohm coil. So don't be too, put off by it's not exactly 4 ohms or 2 ohms or 3 ohms or whatever the impedance happens to be. The other thing is when you're measuring impedance, I've got a red and a black wire here. It does not matter which the polarity is. I mean, this is not like measuring DC voltage. You do not have to worry about the polarity when you're measuring for impedance or resistance. So that's the first coil. Let's by randomly go over here and let's measure another speaker. Let's just see how close they are. And I've not done this yet, so it's kind of new to me. This one's coming in also at 4.1, so fairly consistent. We try to make sure that all speakers are consistent as possible, but that is not always the case. There can be subtle variances, especially after you've been playing them for a long time and you've abused them a little bit. Those coils can change in impedance a little bit as they get damaged. I'm hoping to find one. Here you go. So that one started out at 4.2 and it dropped to 4.1. I got to take our, hat off to the engineers out there. They did a great job of making sure all these speakers are almost identical, as close as they can. So let's measure the coil on the other side. We're at 4.1 again. So that is pretty darn close. About every one of these voice coils is right at 4.1 ohms. So that is using one voice coil. Now, when we're using one voice coil, one of the questions we get asked by people is like, what changes when you only run one voice coil? Well, the only thing that really changes is the power handling. If this speaker is rated at 300 watts with both coils driven to full power, it will only handle 150 watts, or once again, each coil is going to handle half the power. So that's the only thing that changes. The sound does not change. The TL smalls, other than, of course, the power handling, will not change. So there should be no sound difference between a single voice coil and dual voice coil if they're designed correctly. And we have in the past offered the same line of speakers in both single and dual voice coil, mostly in the Comp C line. So this speaker is, right at 4.1. Something else that a lot of people don't know, when you're measuring the DC resistance of the coils, you got to make sure there's nothing causing that speaker to move. So the way that the meter works, it's going to measure voltage going through the coil of the speaker. As the speaker moves, just like with an alternator, if you take a coil of wire and you spin it through a magnetic field, you create voltage. Well, same thing happens with the speaker. You take that voice coil and start moving the cone manually, you're going to create voltage, and that's going to interfere with your readings. So if you see, that's a nice, pretty consistent 4.1 ohms. If I just touch this cone a little bit, you see that meter go crazy? It doesn't take a lot. I can just literally tap it real quickly. So yes, vibrations will make a difference in the readings. So you want to have it in as much of a quiet environment as you can. So that's why your readings might be fluctuating. It should be a dead solid reading if there's nothing causing that speaker to move. So pretty simple. Got a 4 ohm speaker right now, a single voice coil 4 ohm speaker. We're going to hook it up to an amplifier. You're going to get a 4 ohm load. And here in a little bit, we're going to go over the Ernie's dreaded whiteboard, and we're going to show you what happens when you bridge an amplifier, what each channel technically sees for resistance and does for power. So that is basically one coil hooked up. Let's go ahead and wire this in parallel. Now, parallel is pretty simple. If you guys are not aware, parallel is hooking the positives together and the negatives together and then connecting that to the positive and negative of the amplifier respectively. So let's go ahead and grab a couple wires here. I got a big chunk of wires, so we might have wires strung all over the studio before we're done. But we're going to go ahead and take this negative wire, and I'm going to go ahead and connect this back over here to the negative of the other coil. Just literally made a loop right across. In fact, you see I wasn't paying attention. I connected the positive and negative together. Don't do that. I had that happen when I was in Idaho last week. And by the way, thanks to all our dealers up in Idaho. I had a great visit with you guys last week. What pretty country up there. So we're coming out of the negative of the speaker, and I had it right. That's what happens when you're like not paying any attention. All right, so here again, come out of the positive to the positive. And we'll go back over here to actually plugged it in the wrong color the first time. And it does get a little fiddly with all the wires, especially with these push button spring terminals. The easiest thing to do is go ahead and take the wires and twist them together. Once again, it does not matter the color of the wires, as long as we make sure that we get the positive to the positive and the negative to the negative. So go from that negative to this negative, and if you notice what happened to the reading on the meter, the impedance or the resistance actually cut in half. It went from 4 ohms to 2 ohms. So that's how you know that the speaker's wired in parallel. So if you take the way a speaker works and the way a bucket of water works, if I got a big bucket of water and I put a 2-inch tube on it, and we'll consider that like a 2 ohm coil, and I let the water run through that 2-inch tube. If I put another 2-inch tube, the water's going to run through twice as fast. You actually get double the flow, which is essentially like having your amplifier produce twice the power into that lower impedance. So that's what's happening. You got this big reserve of energy, and how fast you let that reserve of energy flow is dependent upon the impedance. So let's go ahead and disconnect all the wires from this one again. That is going to be the parallel wiring. Let's see what happens to the impedance of the speaker if I do it series. This time we're going to take the positive lead, just to keep it straight, connect it to the positive of the speaker. And we're going to take the negative side and we're going across to the other negative. So this is series wiring. So what I've done is I've gone from the positive terminal of one voice coil to the negative terminal on the other coil. If you notice the meter, 17 million ohms. So that basically is an open circuit. I need something to complete that circuit, and that's going to be a jumper wire between the two speakers. So now we'll come out of the positive, go back over here to the negative. And now you see we have 7.9 ohms. So that doubled our resistance. So 7.8, 7.9, a little bit of fluctuation because I think the ventilation's moving in the room a little bit. And one of the advantages I have with this board is the speakers are actually mounted against a solid plate, so there really isn't much that's going to affect the cone. Essentially, they're almost mounted in a vacuum, so that's going to help that cone movement. But even with that, if I touch the speaker at all, you see that reading fluctuate quite dramatically. So a 4 ohm speaker can be wired pretty much 4 different ways. It can be wired stereo, left channel of coil 1, right channel of coil 2. It can be wired in series for an 8 ohm load with 4 ohm coils. It can be wired in parallel for a 2 ohm load, or you can wire just one coil. So that's the 4 different ways you can wire a dual voice coil speaker. And that's one of my trivia questions I like to ask in my trainings. How many different ways? And most people will say 2. Well, of course, series and parallel, but they forget about stereo and the one coil. And that's one of the original reasons why we have dual voice coil speakers, is because back in the 80s and 90s, amplifiers didn't bridge very easily. In fact, some of the amplifiers you had to have a bridging module. So the only way to get more power to the speaker is to put another coil and drive it from another channel. Now we have the advantage that amplifiers bridge very easily, and you don't require any special, other tools or devices to make that happen. So that's one speaker. Pretty simple. This can be 4 ohm stereo, 2 ohms in parallel, or 8 ohms in series. So let's go ahead and disconnect this speaker. Let's go ahead and throw another speaker into the mix. We might not get all the way up to 4 speakers because there's so many different ways to wire this. We don't want to get too confusing. But let's go ahead and take the negative wire, and we're going to go to the speaker on my left. We're going to go from this speaker negative. And as I said, with parallel, you pretty much wire the positives together and the negatives together. You need one more wire. Actually, you need 2 more wires when I get right down to it. All right. It's been a while since I've done this from this side of the board. So negative to negative. Come on, wire, stay twisted together. And we're literally going to tie all of these negative posts together on these 2 speakers. In your comments, guys, why don't you guys go ahead and post what you think the impedance is going to be with these speakers all wired in parallel with 4 ohm voice coils. So 4 coils wired in parallel. What do you think the total impedance is going to be? All right, go back over here to the negative. Now we're going to do the same thing with the positives. But you guys didn't think it took this long just to wire up a couple speakers on a bench. It does take a while. All right. There's the first coil connected. We'll come out of that same wire. And once again, that's also connected in parallel to the meter. We'll go to the next positive. So what do I see for anybody guess what the reading's going to be? Almost sounds like the Superman theme in the background. I'm not sure where that's coming from. It figures. Thanks, Jeffrey, for the music. Oh, I guess I don't need another wire. So, all right, I'm going to go ahead and connect this last wire to the last coil. Anybody guess what the impedance is going to be? Anybody get it right? 1 ohm. So 4 4-ohm coils wired in parallel is 1 ohm. I think now's the time when we're going to jump over to the board over here to see if we can figure out an easy way to determine that. So I'm going to show you the formulas over here. And there's really 2 different formulas to do this. One of them's a lot easier than the other. So go ahead and switch. All right. So the easiest formula is take the impedance of the coils, represented by ohms, divided by the number of speakers. That is the easiest formula. And remember, with this formula, all the voice coils you need to assume they're the same value. So they all need to be pretty close to 2 ohm or 4 ohm or 1 ohm or 8 ohms or whatever the coil is. They need to be mocked up as the same speaker. So we just said we got 4 ohm coils. We have 4 speakers equals a 1 ohm load. It's pretty simple. It's not overly difficult, but what if that wasn't the case? What if we had 8 ohm speakers and we have 4 of them? Now what do you think the total impedance is going to be? Pretty simple. 8 divided by 4, 2 ohms. So that's how you calculate, pretty simple formula, the number of coils divided by, or the impedance of the coils divided by the number of coils. So what if it is in reverse? So we start up back here with the number. So what if we have 2 ohms and we have 4 speakers? What do you think the total impedance on that's going to be? 2 divided by 4 is going to be 1/2 ohm. So that's how it works. If you have more speakers than you have impedance of coils, it's going to be less than 1. If you have a higher impedance than the number of coils, it's going to be higher than 1. So pretty easy numbers to work with. That is one way to do it. But what if, for argument, the coils are not the same impedance. I'm going to show you here in a minute why that's not smart to do. In fact, it may work one way but not the other. But the formula that you'd want to use over that is a little bit more compulated. Compulated? I was thinking about compulations. Anyway, so 1 over R1, so that's the impedance of the coil, whatever it is, plus 1 over R2, plus 1 over R3, etc. As many impedance or coils that you have equals 1 over the total. So this is if your coils are all different impedance. Hopefully you'll never have to use this formula because you never want to mix and match impedance of speakers, sizes of speakers, brands of speakers, types of enclosures. It's consistency. You want to keep everything consistent and the same. So that's one of the other formulas. Now, the reason that I'm going to tell you that you don't want to do this is let's do a little experiment here. I'm going to come back to this here in just a minute. So I've got 3 speakers. They're single coil. I have a 2 ohm, a 2 ohm, and a 4 ohm. I want an amplifier down here that this amplifier is wanting to see a 2 ohm load bridged. Will this work? You guys think this operation will work? And hopefully I can see some comments here. Do you guys think it'll work? If so, how? What do you think is going to be the total impedance that we can get to this amplifier? I don't see anybody answering this one. This one's a little more complicated. I'm not sure what you answered to, Kyle, at 2.33, but it depends on the amplifier. It's 2 ohm stable, no problem. But if it's 4 ohm stable, you definitely don't want to go down to 2.33. This is kind of a trick question. This will work electrically. It'll work perfectly electrically. So what I would want to do to get this 2 ohm total load is I'd wire these 2 speakers in series. So I'd run that jumper between the positive and negative, and then I'd take the positive of this speaker, connect it to this one, the negative, connect it here. So this is going to be your left positive and your negative. So that will work electrically. That is going to give you a 2 ohm load. Well, how does that give us a 2 ohm load? So what we're going to do is we're going to take the 2 ohm and 2 ohm, we're going to put them in series. That'll give us a 4 ohm between these 2 speakers wired in series. I put that in parallel, and this is the symbol for parallel, with another 4 ohm speaker. That's going to give you a 2 ohm final load. Makes sense, right? I think it's raining outside. Hope so, because we really need it. So yes, electrically that does work. Here's the problem, is the speakers are not going to get the same power. So I'm going to draw this a little bit differently. I'm going to draw it as an electrical circuit now. So if we've got, the amplifier plus coming in, and I have the first speaker, and we're just going to consider resistive load. So here's our 4 ohm load. I'm going to put that in parallel with the 2 ohms in series. That's a 2 ohm and a 2 ohm. That's the circuit. I mean, it looks pretty simple. And what we're going to be using, Ernie, can you go ahead and pull up that power chart I sent you an email on? Ernie's going to pull up the power chart, and this is the Ohm's Law power chart, and this has all the formulas that you pretty much need to know. So if we're going to calculate power to the speakers, we're going to use that pink section, that upper left quarter of that graph. Power can be voltage times current. I've said that many times. 10 volts by 10 amps is going to be 100 watts. I can do current squared times resistance, or I can do voltage squared divided by resistance. So those are the formulas. So if we look at this, and let's say we have a total of 100 watts of power coming from this amplifier at 2 ohms, that means this total circuit's got to add up to the 100 watts. So since these 2 circuits are parallel and they are the same total impedance, we're going to divide that in half. So this first speaker is going to get 50 watts of that total power. That 4 ohm speaker gets 50 watts. These 2 ohm speakers over here, you would think they would get more power. They actually get less power. Each one of these speakers gets 25 watts. And if you use the formula, it's pretty easy to see why that's accurate. So 50 watts, 25 watts, and 25 watts, add those together, you get the total 100 watts of power. But if you notice, once again, 25 watts on each of these speakers, those are balanced, but that 4 ohm is getting double the amount of power that each of the 2 ohm drivers is. It sounds completely backwards, but the math will confirm it. And one of the I like to use is the voltage times current is a great one. So just for argument's sake, I have 10 volts and I have 10 amps running through the circuit. That's our 100 watts. So the voltage is going to be the same across here. So this is going to get 10 volts. These two total will get 10 volts, but each one is going to see half of the voltage. We got a lot of numbers up here on the board. So 5 volts and 5 volts is going to add up to 10 volts, and it's the same across the board. So now we can look at this formula here. Let's do voltage squared divided by resistance. So if I take 10 volts, I square it, it's 100, and divide it by 4 as an example. So 10 volts squared divided by 4, that's going to go ahead and give you. Why is this not calculating right? It never works on live camera, but 10 volts squared is 100, divided by the 4 ohms is 25. And if we go over here, you're going to have 5 volts and 5 volts. You're still going to have 2, so 5 volts squared is 25, divided by 2 is going to be 12.5. Same thing, 5 squared is 25, divided by 2 is going to be 12.5. So you can still see by doing the chart, 25 watts here, 12 watts here, and 12 watts here. So it's pretty interesting the way these things work, but never mix and match impedances of speakers and connect them to the same amplifier. It just is not going to work. Kind of brings us back to one of the reasons I drew this up here is, everybody wonders what happens when you bridge an amplifier. You always hear, how many ohms each channel is going to see. So if I take a 4 ohm speaker and I bridge it to this amplifier, and let's say this amplifier is stable to 2 ohms again, that's its minimum impedance. So it can run basically like this. 2 ohms and 2 ohms. So that's the minimum impedance. This amp will run 2 ohms stereo. So we always tell you that if an amplifier is 2 ohms stereo, you have to double that impedance for its mono rating. So that means it's only stable to 4 ohms mono. And the reason being, these two terminals right here, the left positive and right negative, are exactly the same electrical terminal. They're wired together. If you take that ohm meter and measure between those 2 points, it is a dead short. In fact, there's usually only one trace that feeds that whole circuit. So I could replace this. Actually helps if you use the right side of the eraser, the correct side. So I could basically replace that with this, and like I said, if these two terminals are the same, it would basically have a connection there, but you really don't see that connection, and neither do the speakers. So 2 ohms and 2 ohms, well, 2 ohms in series is going to be 4 ohms. It's basically the same as that. So that's what happens when you bridge an amplifier. Each channel is going to see half the impedance. And if this was producing 100 watts of power, you're going to get 100 watts total, or 50 watts here and 50 watts here, or the total over here would be 100 watts. So I hope that answers some questions. Jeremy, do we have any good questions anyone's asking? Yes, he says yes, so he's going to throw up some questions. Hopefully that makes sense. Hopefully that describes a little bit better what happens when you bridge an amplifier, at least new amplifiers. Older amplifiers did not have these two terminals tied together. They were 2 different circuits, therefore you couldn't do this, and to bridge them you had to have that bridging module. So what do we got for questions, JW? All right. Can you accidentally damage the speaker if your multimeter is in the wrong mode? Yes and no, really. You're not going to damage the speaker by measuring it. If you wire it wrong, and once again you measure it wrong, anything can happen. Now most of the time when you set the meter to the wrong setting, it's not going to read right. So let me give you an example. Let's go back over to this meter. Get these wires out of the way so hopefully you can see it. So right there, I've got that meter set on impedance. Well, if I set the meter wrong, if I set it to frequency, it's going to measure 0. No frequency, no hertz. If I send it to millivolts, I get no reading whatsoever unless I start moving one of the speakers, and then it will actually give me a voltage reading. If I set it to amperage, there's no amperage flowing. So in this instance, no, there really is no way you can misread the speakers. It's just not going to give you a proper reading at all. Now, what can happen with some meters that have a range, a lot of your voltmeters, your multimeters will start with like 0 to 2 volts, 2 volts to 20 volts, and then 100 volts, and then 200 and up, depending on what the manufacturer wants to use for a scale. If you're trying to measure an impedance of a speaker, the easiest thing to do is to figure out, all right, I know that the speaker is supposed to be 2 ohms. I want to set the meter for the next setting higher than that reading. So let's go ahead and show you that. Let's go ahead and disconnect all this. I say someone's going to have to get the spaghetti sauce before we're done with this because we're going to have a lot of wires going everywhere. So let's go ahead and hook this up. I'm going to put all these speakers, these coils in series. So positive to negative on the meter. And here again, it doesn't matter what color wire we use. We're going to go ahead and wire this in series. I'm probably not going to be able to do this because I just remember that meter doesn't have a range setting. So if I were to set this at the 2 ohm setting, so if your meter has the different notches for the ranges, it's going to say overload or just not give you a reading. So if your reading is above the meter's range, it usually gives you like an OVR readout on the display. This one automatically ranges for you, so it's a lot easier to operate meter. But to answer that question, you really can't damage the speakers unless you haven't measured it right, you're not sure exactly what the measurement was, you have the speakers wired to a 1 ohm load, the amp's only stable to 4 ohms, and you distort the heck out of it and burn up the speaker. Well, you didn't burn it up because of the way the meter was connected to it. You just ran it too low of an impedance for the amplifier and you weren't able to measure that. So I suggest, practicing with a meter, just basically grab the leads and grab a speaker and, just start touching the positive negative leads. And here again, different wiring configurations. So this is going to be an interesting one. I'm going to see if I can do this. I've never tried to do this on a display. Let's go ahead and take these 2 speakers and let's wire all the coils in series. And while I'm doing that, if you guys want to give a guess to what you think the total impedance is going to be, I'm curious to see what you guys come up with. So we're going to wire all 4 voice coils in series. So we're going to go first voice coil. We're going to connect the positive. I'll do this, keep the wirings the same. So now I want to run a jumper between these 2 coils. So I'm going to go from the positive of this coil to the negative on this one. Now we're going to go from the positive of this coil to the negative of this one. I bet you can figure out the next step. Positive of this coil to the negative, actually, of this coil. That leaves one more connection. If you notice that meter says overload right now, that's what you're going to get. That OL means overload, means that an impedance is higher than this meter can actually measure because it's an open circuit. So I'm going to take the very last wire. I'm going to complete this circuit with all 4 coils in series. Anybody got any numbers up there? Let's see. It looks like the audio guy there, SC audio guy, I think you said, 16 ohms. Eric said 16. That should be correct if I wired it correctly. Were we right? I don't think we're too far off. You're again between 15.7 and 15.6 ohms. If you got an amplifier that's designed to produce its maximum power at 1 ohm, you're not going to get a lot of power out of that amplifier the way it's set. And on top of that, it's going to divide that power between all 4 speakers. So how much would that be? What would be the difference? So let's go back over to the board over here. I know we're going to drive Ernie and poor Steven nuts. But let's show you how important this is. And this is strictly the mathematic end of it. It's not going to be the actual, result all the time, because the amplifier really has to be capable of doing this. So if we have an amplifier that's designed to handle or produce 100 watts at 1 ohm, if I double this impedance to 2 ohms, it's going to produce half the power. If I double the impedance again, it's going to produce half the power. I double it again to 8 ohms, half the power. Go up to 16 ohms, I now get 6.25 watts per speaker. That's what the amplifier can do. 100 watts by 1. Down here at a 16 ohm load, it's producing a total of 6.25 watts. We say that's by 1, does that mean each speaker gets that power? No. They divide that power between the 4 speakers. So literally each speaker is getting 1.56 watts of power. Now up here, same thing. If you got 4 speakers, you divide that 100 watts by the 4 speakers. Each speaker is getting 25 watts. So hope that answers some questions about what happens when you bridge things and what happens with the impedance. It's pretty important to do things right. Doesn't matter on the gauge of wire. Not necessarily. Obviously, you want to run good oxygen-free copper wire. The problem is that you get a lot of people who's like, oh man, you got to run at least 12 gauge wire on subwoofers. Well, with anything with wire, it depends on the current, the voltage, and the distance it's got to run. In most cars, 16 gauge speaker wire is adequate for mids and highs. 12 gauge, 10 gauge is perfect for subwoofers, because you're not running it for miles or hundreds of feet. You're not running 50, 60 amps of current through it. So it's not a problem. Just use good quality wire and just use good common sense. I generally run 16 gauge speaker wire to mids and highs, and 12 or 10 gauge speaker wire to subwoofers. Unless you're doing the SPL applications, now start talking about the Warhorse amplifier. It's got 4 gauge speaker outputs. But you're looking at 4,500 watts of power, not 100 watts. So big difference there. Just good speaker wire, good power wire, good ground wire, and once again, you want to make sure that you have very, very good connections, and we'll show you why that's important later. But this formula that Ernie put up there that I have, tells you you can calculate power, you can calculate current draw, you can calculate resistance or voltage for any given component in a circuit. So this is kind of the magic chart, the Ohm's law power chart. So if you guys don't have it or are curious how to do this, just get this and just do some practice, wire up some speakers and see if you can predict what it's going to be before you actually measure it. So what's the next thing we need to do? Well, we just saw 2 speakers, series and parallel. What if I did a series parallel combination? Can you do that? Can I wire those speakers series and parallel? It's a little bit more difficult, but let's go ahead and look back over here and let's see if we can do it, and let's see if we can guess what it's going to be. And while I'm wiring this up, I know some of you guys will probably get it. Somebody out there, guess what the total impedance is going to be. I wish we planned this ahead. We actually had prizes to see who got it first. So we're going to wire it 2 different ways. We're going to wire the speakers up in series first, and then we'll go back and wire them in parallel. Then we'll go back and wire each speaker in parallel, then wire the 2 in series. So we're going to do 2 different ways. So first thing we're going to do is going to wire each speaker in series. And I like to start with the coils themselves, or the speaker itself. So I'm going to go from the positive terminal here of this side to the negative terminal on this side. So that took that 4 ohm speaker and that made that an 8 ohm speaker. Let's do the exact same thing on speaker number 2. So now I have essentially 2 8-ohm speakers. If I connect the positives together, I'll have 2 8-ohm speakers. So now it's going to be a little more tricky. So what I want to do is I want to go ahead and wire these in parallel. So that means we're going to go ahead and connect the negative of this speaker to the negative of the other speaker. It's been a long time since I've done this, guys, so hopefully I wire it right. All right, actually, so that should give that a 2 ohm load. All right, so now I want to go from, I'm getting too many wires here. So, all right, positive to positive. All right, now I'm going to wire this positive, or this, actually, yeah. Why did I do that? See, I'm getting confused already. All right, I'm going to go back and redo this. Technical difficulties, guys. I know, everybody's laughing. He did it wrong, I think. I'm not even sure if I did. All right. So, that's what happens when you get too many darn wires. And I told you, this one's the one that's more complicated to do. All right, so we are seriesed again. It's now in the meter. I want to wire the negative of the meter to the negative of this side to the negative of this side. Then take the positive to, so grab the wrong wire. Let's say we get too many wires. So, all right, so we got basically these two wired in series, so 4 ohms and 4 ohms is 8 ohms. Now I've taken the meter connected to one terminal. Now I'm going to go from this negative terminal to that negative terminal. So that's part of your parallel connection. Let's take the other side of the meter, which is the positive terminal, and we're going to go from the positive side of this coil to the positive side of the other one. Now, if I wired it right, what did we have for guesses for impedance? Anybody see up there? Did anybody get it right, JW? Well, I think what CM, is that right? If you can see what the total impedance is now, it is 4 ohms. So 4 coils wired in a series parallel combination is going to give you basically the same impedance as 1 coil. So take 4 ohms in series, 8 ohms, 4 ohms in series at 8 ohms, 8 ohms in parallel with another 8 ohms gives you a 4 ohm load. So hopefully that makes sense. Hopefully you can see that. We're actually at 4.1, which is, yep, as it moves, it changes a little bit.
A little glare on it.
Oh, a little bit of glare on the meter. That more gooder? Yep, okay, I can see it in the monitor over here. So let's get a little trickier, guys. Let's add another speaker into the mix. I know you guys that are doing the SPL out there with multiple woofers. I know you guys have done this a lot of times and probably pulled your hair out. Start to look like me when that happens. So let's go ahead and just disconnect everything. I apologize for the little screw up there. It's been a long time since I've had to do a series parallel combination on speakers that were just sitting out in the open like this. Like anything, it's a perishable skill. Just going to keep practicing with it. All right, so let's put a third speaker in. Let's go ahead and do it in parallel. So we got our meter connections. We're going to go to the negative and the positive. All right, good trivia question. Let's have some guesses what the net impedance is going to be now. We're going to put 3 woofers all in parallel, all 4 ohm coils. All right, so positive to positive. Oh, that one fell out. I wish there was a way to do a time warp and actually get this to jump ahead a lot quicker. All right, so here we are. Man, it's really raining out there. That's good to hear. We have needed some rain. You see why I made 8 of each wire. I hope I made enough. And if you notice, I'm connecting literally positive to positive all the way across. So there's the first 2 speakers all connected. All right, another jumper here. Let's go down to the bottom speaker, and we're going to throw it into the mix. My meter's arguing. I think it's telling me the battery's low. All right, so that's all the positives connected. Just glad these are push button terminals. All right, so now we're gonna go to the negative side. So this wire is connected to the negative here. To the negative there. To the negative. And this is going to show you guys something else. It's always wise to keep your wire runs just as long as they need to be so it doesn't get quite so confusing as we have here. All right, assuming I got it all connected right. Move some of these wires so you can see the meter. So this is tying all the positives together. What did we think the impedance should be? Do we have any guesses? 1.33, I think Elise said. I think that's, or is that alias? I can't read from here. Type is 1.33 seems to be the common guess. Let's go ahead and connect the meter and let's see what we get. Interesting. It says about 1 ohm. So actually 0.8. So one way to figure that out is to take all the coils. So we essentially have 6 coils at 4 ohms. So let's take the impedance, 4 ohms divided by 6. So it's definitely going to be less than 1 ohm, but we've got a little resistance in the wires. So once again, if we go back to that formula, the impedance of the woofers divided by the number. 4 ohm coils, and we have 6. So 4 divided by 6 should be the answer. All right. Now let's go series. Let's do 6 coils in series. And we're not going to go clear up to 4 speakers because I know you guys are going to be excited to see who wins the prizes tonight. But let's do everything in series. So, the way we do series, we're going to start off with the connections. We're going to connect one side. We'll start with the negative. And then we're going to go from the positive of one side to the negative on the other. The positive on the first one to the negative on the second one. Positive to negative. Positive to negative, positive to negative, and then you have one terminal left, which is the positive to connect to the amplifier. So if we do that formula, series is you literally just add all the impedances together, no real major calculations to do. Try to keep that meter off the display, or that wire. So we get a 23.4 ohm load, which once again, 4 ohms times 6 coils should be 24. So we're pretty darn close. So that should give you an idea, the different ways you can do it. And I'm not going to get into the series parallel combinations wiring with 3 speakers. That gets really bizarre to do. And if you're going to do that, I'm just going to give you a little trick. It can be done. The key is you have to split one speaker. So 2 coils off one speaker, 1 off the other. Then the other coil goes to the other 2. That's the combinations you would do to balance that load out. So once again, it's a lot more difficult. So I would literally run these in parallel with this coil. So all 3 of those in parallel, and then parallel with those. Those would be in parallel, and then series these 2 groups together. That's how you would do that. And it, like I say, it gets a lot more complicated, a lot more wiring, but still not too bad. Now, here's an interesting thing. You have to keep the polarities correct when you're actually wiring this. We're doing DC. So we're just measuring resistance. So there is no AC, there is no current flow. So positive, negative does not matter as long as you get the right coils. But if I'm running an AC signal through these speakers, you have to get the polarities correct. If you don't, and this is what happened to one of our dealers that I was at up in Idaho last week, he had the positive and negative flipped on one side of a dual voice coil speaker. So that meant one coil was pushing against the other coil, which was pushing. So that was literally 100% distortion. So any power coming out of that amplifier was 100% heat. Nothing was converted into movement or sound. So that's why you got to have that happen. Now, if you got 2 speakers and you got this in parallel and this in parallel, and you wire them out of polarity that way, you get one speaker going up while one's going down. So you can have the coils wired properly in each speaker, but have them out of polarity when it's connected to a second one. So the easiest way to tell if you have it right, especially with multiple speakers, is get yourself like a, if you're doing a lot of speakers, get like a Makita battery or some good battery, because when you go from the battery, you can actually touch the negative of one speaker to the negative of the battery. Then the second you touch the positive of one connection to the positive of the battery, those speakers will move in one direction only. Now, if they're wired correctly, to tell if the speaker's in polarity, if you have the positive to the positive of the battery, the negative to the negative of the battery, they push out. If it's out of polarity, they pull in. But if you pop the speakers with the battery like that, and just real quick, you don't need to leave it connected for very long because you can burn up the speakers doing that. So it's just a real quick pop to test it. If you get some speakers go out and some go in, they're out of polarity. Or if a speaker doesn't move at all when you do that, it's out of polarity at the speaker. So that's one way you can test that. So I wanted to make sure you guys understood that it doesn't matter in DC, positive, negative. It does matter in AC. I went ahead and made sure that I did everything in the right order just for sake of connections. But pretty cool stuff, and it's not too terrible. We're about 3 minutes away from the closing of the contest. We still got some of that fun housekeeping stuff we're going to do, but I'm going to go ahead and sit down over here. And I think we're going to switch camera angles because I think we're done back here. Let's see if you guys have any other questions on anything that we've been doing. I'm sure JW's got some all lined up for me. So, all right, let's stump the chump. Me being the chump, and yes, I have been stumped before. So, are the lengths of your voice coil wires at a standard and compatible length? Clint, I'm not sure what you mean by the length of your voice coil wires. Are you referring to the wires inside the voice coil or the wires going to the voice coil? It shouldn't really matter. All the voice coil wires internally should be exactly the same length, same gauge, and wound the same. That way you're going to get the same impedance for both voice coils. But you do not have to worry about, the wire going to one speaker is, 3 feet long. The wire going to the other one is 10 feet long. As long as the wire's good gauge, there's not going to be enough resistance in that wire to really cause a change. So hopefully that answered the questions. The two different parts of that question are two different ways I could interpret the question, because yes, there's many different ways you can do that. All right, what else we got? Jeremy Shupdog. Does it matter if you split at the speaker terminals versus split at the amp? No, it does not matter. They're all electrically the same connection. So that's a great point. You can literally take the speakers we have back here, and I can jumper the wires. If I'm doing parallel, I can jumper the wires across the speaker itself, or I can take the wires of the second coil and run them clear back to the amplifier. So no, as long as there's solid copper between them and no voice coil, which has got resistance, there is no difference in electrical connection. So that is a great question. So very good question. Appreciate you asking that one, because I was actually thinking about that earlier and would have forgot it otherwise. But yep, you can actually wire it at parallel at the amp or at series at the amp. It does not matter. So Brian Park says, does a multimeter help if you detect you wired out of phase? No, it will not. Well, indirectly, I'll tell you why it can. Pull the battery out of it and use the battery like a 9-volt battery. With smaller speakers like mid-ranges, you can actually see with a smaller, like a 9-volt or a 1.5-volt battery, that actually will have enough current that you can see movement of the speaker. But the multimeter cannot detect polarity. It's only measuring DC. Now, it will measure AC voltage, but once again, it will not tell you if anything's out of polarity. There's no way to do that with a meter. Another great question. And you guys are full of the good questions. That's why I like doing this show, guys. I like answering questions, and there's a lot of stuff that, I forget about that is actually probably pretty important to you guys that, I take for granted. So, got another one there, JW. Guys, I hope you're giving Colin some crap back there for his first night here. We don't want him to think he's got it too easy. So, Jason, WW2000, Q for kicker. Why do some subs have a lot of impedance rise, 2 to 3 times, etc., and some have very little rise, like 1.3 times? It's a head scratcher. Well, the impedance rise has a lot to do with the type of enclosure and the volume of enclosure. So that's where they changes. When we talked about before, what impedance rise is, the speaker's a nominal 4 ohms might have a DC resistance of 3.6 ohms. When you put that speaker in a box, it's going to change the impedance depending on frequency. So that's the big key. And it also depends on the teal small parameters of the speaker, how big the voice coil is, what its inductance and capacitance is. It gets really interesting, but really the biggest culprit for impedance rise, and it's not really culprit because, it's a fact of life and you just have to know it's going to be there, is especially a ported box reaches the maximum impedance at the tuning frequency of the enclosure. So if you've got a device that you can measure impedance and you got a frequency generator and you start varying that frequency up and down, wherever, if it's under 100 hertz, I mean, obviously it's going to do something really goofy when you get to the next octave. But if you're tuning a box at 40 hertz and you're sweeping between 20 and 80, wherever that impedance curve is the highest, that's the tuning frequency of the enclosure. Now it's the opposite on a sealed. It's going to be the highest at the tuning frequency. So therefore, it does make a difference on, how things are wired. You see this a lot of times when people talk about, hey, I've got my subs wired to 1/8 of an ohm load, but your amplifier is only stable to 1 ohm and it doesn't shut off. That's because at a single tone burst, that amplifier might even be seeing more than, can be seeing 16 ohms. I have designed a dual bandpass enclosure back in the days when Orion did their tech briefs. It was I think it was a 10-inch woofer. I put it in basically a vented bandpass box. It was a dual 4-ohm voice coil driver, and it actually got to 122 ohms at one frequency. It was like at 112 hertz. It was way beyond its actual applicable range. But like you say, outside of the tuning range of the speaker, the impedance does some really crazy things. So that's kind of what happens with the good old impedance rise. And, speakers react differently. They're built differently, different diameters of wire, and once again, the different lengths and different impedances of the windings. Therefore, your electrical parameters, your teal smalls, will have a great effect on how, that impedance curve actually changes with the type of box and the size. Yeah, even the box volumes will change where that impedance rise happens. So it's really dependent on the enclosure. It's a whole tuned system at that point. It's just everything working together, and that's the result of it is you get something called impedance rise. So cool. Any more questions there, JW? I think we'll take like one or two more. Tools and things. That's a neat handle. It's like, why do higher ohm loads play better in sound quality? It's interesting. There's been a lot of debate over this. It has to do a lot with what we call damping factor. The higher the impedance, the basic more control your amplifier is going to have over the speaker. So the big question I always like to ask is, if I have 1,000 watts at 4 ohms and 1,000 watts at 1 ohm, what's the difference? And most of the time people will say 1,000 watts at 1 ohm is louder. Well, it's not any louder. It's actually the same exact volume. 1,000 watts is 1,000 watts. But you're going to have a little bit better control with the amplifier running at 4 ohms producing 1,000 watts, and the amplifier will be a little bit more efficient. It's going to pull less power. Still produces the same power on the output, but produces, or on the input, but produces the same power on the output. And that's what we call, efficiency is power in versus power out. The higher the impedance, the higher the efficiency of the amplifier. So it can use the power coming in much better. So another great question. So I like running as high impedance as possible. And in fact, you start looking at it, car speakers are generally, 2 or 4 ohms. Home speakers are generally 8 ohms because you don't have all the road noise that you're trying to, that can mask that distortion. So then when you get into PA gear, you're looking at an average of 16 ohms, and then you get into your headphones and earbuds, and they can be, 32, 46, and they're right in your ears. So, if there's any distortion, you're going to hear that. So the higher the impedance, the cleaner the overall signal's going to sound. So another great question. Let's take one more, and let's get back to the rest of the exciting things going on. Living Loud with Andy. Actually, don't forget to tune in to Andy Night. 54,000 plus members in Kicker Club. So if you guys are new and not a member, you need to sign up for Living Loud with Andy and watch him following this show. He'll probably be a little bit of a break after the show, but he will be on tonight. Andy says, why is there only a different final resistance in series parallel or pairs when 3 or more coils are in play? Always made me wonder. Appreciate you, John, and the team. All right, so let me see if I can read this. Why is there only a different final resistance for parallel series or series parallel when 3 or more dual voice coils are in play? I'm not exactly sure what you're trying to get at, but ideally, the speakers, either wire them in series at the speaker and then parallel at the amp, or in parallel at the speaker, series at the amp, should give you the same exact impedance as long as things are going. But just remember, if you have a speaker, a series of speakers, or even a single speaker with the coils wired in series, and you burn up one coil, you've opened that entire circuit. So you can have 24 speakers wired in series. If one coil burns in half or one tinsel lead breaks, it shuts them all off because there's no longer a consistent circuit. So, Andy, we might have to talk about this a little bit later after the show and figure out exactly the question, because I'm not sure I'm quite understanding the question. Of course, it's late and it's raining. It's actually pretty loud in the studio here, which is kind of cool. So, awesome. So that being said, we got a few other things we like to do at the end of each show, besides give stuff away, and we'll do that at the end of the show. We've got, let's go to questions. While I try to wake up my laptop, it can be waking up while I'm reading questions. And some of these questions I picked really because a couple of them actually kind of related to tonight's show. Which the first question was, what's the difference between bridging and strapping amplifiers? So if you guys have heard those terms, bridging and strapping, they are two completely different terms. They do mean two completely different things. If you have a 2-channel amplifier, you can bridge the amplifier into a single channel. So that's bridging. That's taking 2 channels of an amplifier and giving them one singular output. Strapping is when you take 2 separate mono amplifiers and make them drive one output. So that is the difference between bridging and strapping. Now, when it comes to strapping amplifiers, we go back to those buzzwords that people like to throw around, full bridge and half bridge. And once again, I don't know how much we have to stress. It doesn't matter if you have full bridge or half bridge. As long as they're designed correctly, there is no better either way, unless you're going to strap amplifiers. you can only strap half bridge amplifiers together. So if it's a full bridge, like the Warhorse or a full bridge, you cannot tie two of those together to make one output. They are already internally set up as a full bridge amplifier. So that's the difference. Full bridge, you cannot strap, but half bridge, you can strap two separate amps to one coil, and bridging is taking two outputs of one amplifier and turning them into one output. So this was another really good question, and I've been holding that one for the time when we did this, so that's kind of cool. All right, next question is, why can't I measure the impedance of a component set at the crossover input? And the reason being is crossovers have capacitors and resistors and coils in them. So they're going to completely change the reading that you're going to get from the meter. So that is the other confusing thing. You actually have to use an impedance meter when you put that all together. Now, it is interesting. A lot of crossovers out there are 12 dB per octave crossovers for high pass on the tweeter alone. So 6 dB per octave is a coil. Usually the coil's on the positive of the tweeter. If the tweeter dies, it's just an open circuit, no big deal. But if you have a 12 dB per octave crossover that has a coil and a capacitor, the capacitor is on the positive input. The coil is actually running across the positive and negative. So if you burn up the voice coil in a tweeter, you no longer have 4 ohms there. You are literally running all the power straight through the coil, which may have a very, very low impedance. It may have a 1/4 of an ohm. So that's why if you blow a tweeter, sometimes it will put your amplifier into protection mode at higher power, because it's seeing that as a dead short, because no longer do you have the tweeter in parallel with the coil to give it a higher impedance. So great question. If you need to know the impedance of a component set, you've got to use an AC signal and an impedance meter. So here's another funny question, and I ran into this one a couple years ago as well. It says, how much more power will my subwoofers handle if I remove the magnet boot? So you think it's like a big sweater keeping the magnet, heat inside. Well, if I look at this speaker, which you just happen to have this 7-inch mid-range up here, we do have a boot on the magnet. This boot actually serves 2 purposes. The first purpose is it makes it look nice. It's purely cosmetic. So it does make the speaker look great. It doesn't give it that unfinished look. But the one mechanical thing the boot does, if you're pulling speakers out of an enclosure, frequently and setting them down, the magnets are actually made out of usually cobalt or strontium. It's a ceramic type of material. Now, ceramic materials and hard surfaces don't mix. I don't know if you've ever knocked your coffee cup off onto a concrete floor, they explode. So that's another thing this magnet boot does, is it helps you from chipping the magnet or breaking the magnet should you bump it on concrete or something solid. So cosmetic and for looks. Why it doesn't affect the performance of the speaker is I just mentioned that magnet is made out of ceramic, and that material is an insulator. So ideally, the magnet will never get warm. The key is if the magnet boot covers up a bunch of the back plate. This is the heat sink for that speaker. So if I wrap that boot all over the back of this, that will affect the cooling characteristics of the speaker, and that's going to be bad. Now, it depends on if you're pushing the speaker, to its limit, it's getting hot. If you're not running it very hard, it isn't going to make much of a difference. It should still dissipate heat. But, if we're splitting hairs, yes, if the boot covers the back plate of a mid-range or a woofer, it can decrease the power handling. But normal applications like the way we use our magnet boots, it will not affect the power handling. So another cool question. That's pretty awesome. You guys did a great job with that. So let's move on to the second segment. Let's talk about a little bit of things that are coming up around and some cool things going on before we get to the fails and the installs and the giveaway. I think we're going to be almost on time tonight. We're doing good. So if you guys ever want to know what's going on in the KICKER world, you want to find out where we're going to be, if you go to our Facebook page and you click on Other, and then you go down to Events, it'll list all the events that we're participating in one way, shape, or another. And there's always a bunch of the American flat track races going on. Lauren is our great ambassador for that sport. He hits, I think, every one of those. It's pretty amazing all the coverage he gives us for that, and he's there just hammering out the KICKER tunes all weekend, and he does a great job. But American flat track's going on almost every weekend. Bass Wars, there always is some Bass Wars competition going on, and thanks to you guys for putting those on in your regions, and thanks for supporting the KICKER brand. Cars and Coffee, if you're here in the Stillwater area, this Saturday from about 8 to noon, we're going to have our Cars and Coffee here at the company facility. We usually average anywhere from 100 to 250 cars, and we've always got door prizes to give away. No, purchase necessary. We give some stuff away and a lot of other local vendors. And there's actually another Cars and Coffee going on in Oklahoma City. Those guys just had a trailer built by our friends at Audio Midwest in Edmond. They put a big kicker system in the trailer that's featured at Coffee and Cars in Oklahoma City, so you can go check that out. I think they're the third Sunday morning. I can't remember, or Saturday morning. I can't remember for sure, but that's another great one. Tuesday here at the Kicker facility, this is kind of an interesting event. My really good friend Rick Love, the president of Vintage Air, they make aftermarket air conditioning systems for street rods and to replace worn out systems in other cars. They're going to be doing their own cruise. They're leaving San Antonio. They're having a big kickoff party at their facility on Sunday night. Monday, they're going to wake up and drive from San Antonio up to Guthrie, Oklahoma, spend the night. Tuesday morning, they're going to get up and they're going to head here to the Kicker facility. So if you guys are in the Kicker area, Tuesday between, probably about 9 o'clock to noon or so, we're going to have 80 absolutely amazing street rods. I mean, we're talking cars that, may be $1 million or more. This is a really, really popular event for Vintage Air. So they're actually going to make a couple other stops. They got a couple vintage car collections they're going to go see. They're going to go up and see the American Speed Museum in Lincoln, Nebraska, which is my hometown. That's at Speedway Motors. They're going to stop there, and they're going to end up at the Good Guys Heartland Nationals car show in Des Moines, Iowa. And that is a big show. There's over 5,000 cars, and that'll be July 5th, 6th, and 7th at I think it's at the fairgrounds in Des Moines. So that is a huge car show, and it is a lot of fun. And as always, don't forget, Living Loud with Andy tonight. Tune in, ask him all kinds of questions. He's always got some fun stuff going on and has some fun guests. 54,000 members in the Kicker Club. Andy, thanks again for knocking it out of the park. And once again, we still can't do any of this without all your guys' support, so thank you. Other exciting news, Warhorse are shipping. If you haven't heard the news, you saw some of them in the Slamology. Those were some pre-production pieces we have air freighted in. But yes, the Warhorse 3601 is shipping. They passed all the QC, so they're on the way. The accessories as well, the power distribution blocks, the battery terminals, the power wire, little volume control, the RCA level inline volume control, the passive piece, that's available. Once again, all the Warhorse and accessories are shipping now. The 3601, the 1004 will be shipping very soon. We now have back in stock the TWS2s. Those are the in-ear true wireless earbuds that have the little silicone insulators. I love those. I travel with those on the plane all the time. Man, they sound great, and they're pretty darn affordable. I think they're $40. I'm guessing on that. I'm not a price guy, if you guys know, but I think they're only $40 retail, but they sound great, and they do obviously work, hands-free for your phone. The KXMA 1500.1, that's our 1500 watt mono subwoofer amplifier in the KXMA line is now shipping. We've been out of that one. Actually, that's a brand new model. It's just taken a while to come to market. And we've got a new marine coax. I actually have one right here next to me. This is the KM614L. This is a great little it's got a shallow mount grill on this speaker. 6.5-inch coax speaker. It's 60 watts power handling. If you guys can see by all the wires coming off the back, it is full RGB LED lighting. And it's got this great white grill that snaps on. Really good, so it doesn't fall off. It also comes with the silver grill. So you get both the white and the silver grill in the box. And I'm not sure if you can see this. Maybe you can by this camera angle. The surround in the speaker is actually inverted, so it actually rolls down. And that's what helps give this speaker its really slim profile. It doesn't affect sound. I mean, surround is surround as long as it, does what it needs to do. So it's not going to sound any different if it was the other direction. If it was actually coming out, it just would hit on the speaker grill. So by inverting that surround, we can actually make this a lot shallower mount. And these are already in the warehouse, and they're going to retail for about $210 a pair. These things sound great. So those are the new products that are shipping. So that being said, 8:47, I think we're down to the point where it's time to give some stuff away. Unless JW or Colin or Ernie back there, you got anything else exciting that we need to cover tonight? Anything you can think of? And we hear static from the back. So apparently they are not listening to me, which I can't blame them. They're just watching their screen. So, guys, what? Now he claims they're listening after someone probably nudged him. But we're going to go ahead and give away our prizes for the night. And thank you guys again for your support. Tune in 2 weeks. I can't remember if I'm doing that show or not, but if I am, I'll see you in 2 weeks. If not, I'll see you at some point after that. It's always fun doing this and fun hanging out with you guys, and it's fun being able to do these demonstrations. So, and I'd love your questions. So support@kicker.com. If you guys have any questions we didn't answer tonight, our tech department, those guys are awesome. Or you can ask Andy Knight on his show. Chances are he'll have some people on there. He'll be able to answer questions for you as well. So if this has piqued your interest, and you've got some questions that we didn't get answered, don't worry, you can get those answers either through us or Living Loud with Andy. So who is the runner-up? Who's going to win the EB400s, the Kicker Unmasked koozie, and the t-shirt there? I think, Colin, are you in charge of this? If that's the case, it looks like Kevin H. from Kentucky. Kevin, watch for an email from our crew. We're going to ask for your name, your address, and it's got to be an actual physical address, not a P.O. box, and your phone number. They will not ship without a phone number, and, of course, your shirt size. So we want to make sure we get that right. So congratulations, Kevin H. from Kentucky. The second place or runner-up winner, which is going to win the, I forgot which one. That was the TWS2s. So you're going to win those little Bluetooth in-ear earbuds. That's Devin S. from Tennessee. So, Devin, once again, congratulations. You're going to get a set of those free TWS2 earbuds, the Kicker koozie and t-shirt with the Unmasked logo. So, congratulations to you as well. And that means we're down to our final grand prize winner tonight, which is going to be, drum roll please, looks like Sydney S. from Michigan. So it's obviously a little bit cooler up there in Michigan, but congratulations. Sydney, appreciate you guys and all you guys for, registering for the contest. And, talking about cooler, it was kind of funny when I was up in Idaho last week. I woke up Wednesday morning, and it's already been 103 here in Stillwater. It was 37 degrees. So, yeah, I was a little disappointed I didn't take a jacket. But that's poor planning. But you guys plan on being here Tuesday night, 7:30 Central Time on the Kicker YouTube and Facebook channel. And we will see you guys again then. Thanks for tuning in, and have a great night. And guys here in the studio, I hope you brought your umbrellas because it's raining cats and dogs out there. I know, I just stepped in a poodle.